Welcome back. This is Dr. Kofelt again, and we're going to do the last part of this first chapter in Chem 111, and this will conclude the Module 1. So you need to get on all of your homework and all of that stuff and get that taken care of. So in this last part, this is one of the most important things you're going to do in chemistry. You must learn how to do dimensional analysis. And we're going to start out slowly so you can kind of get the hang of it. But we are going to use this throughout Chem 1, and if you take Chem 2 and beyond, and you can use this technique in more than just chemistry. A lot of nursing students use it continually through their career. Engineers use it, so it's something that you really need to understand and learn how to do. So when we are looking at things, we saw when we were looking at temperature, for example, we had to convert the Fahrenheit to Celsius, okay? And basically we were using a formula for that, okay? In the case of converting one unit to another, though, often we are going to use conversion factors. And what conversion factors are is they show how those two things are related to each other. And so because they are related to each other in this specific exact way, we call that an equivalence. That is, 1 inch is the same as 2.54 centimeters. So if I measure that on a ruler and I have one that's got inches and millimeters or centimeters on it, I can look at that and I can see that the 1 inch mark lines up with the 2.5-ish mark on the centimeter scale. And so they are equivalent. And so when something's equivalent, then I can either write them like this or I can write them like this, because 1 divided by 1 is 1. 2 divided by 2 is what? Not 2, 1. 4 divided by 4 is 1. Okay, now wait for it. X divided by X is 1. The rule in math is anything divided by itself equals 1. Okay, so since 1 inch is the same as 2.54 centimeters, then 1 inch over 2.54 centimeters is also 1. So it's considered to be an equivalent. And since it's an equivalent, I can write it with the 1 inch on top, or I can write it with the 1 inch on the bottom. The way I decide which way I want to do it is because what I'm going to be trying to accomplish here is to get rid of certain units and be left with others. Now you have a conversion list in your exam materials, okay? So make sure that, and it's also, I believe, in the workbook. So make sure that you have that out because you're going to be looking at that some to do these, okay? So I just like to list a summary sheet for you here, or slide, so that you have all the steps in one place, okay? And so that's what I'm doing here. So when you're solving for dimensional analysis, you're going to take inventory and then you're going to translate your units. And I'm going to show you what all these mean, okay? You're going to start with what you can measure, or what I say is start with what you got, what you can hold in your hand. Know your final destination, okay? When you in a line, write an equal sign at the end so that you know, and put the units that you're looking for so you'll know when to stop, because sometimes you don't. Sometimes you keep going, you get into it so much. You plan the trip by getting rid of each of the units as you go along. Once you've done that, and you can cross those out, okay, because you've got a milliliter on top and a milliliter on bottom. Once you do that, you can cross those out because milliliter divided by milliliter is 1. Then all you have to do is do the math. So you multiply everything on top, divide by everything on the bottom, and then that's your answer. And then make sure that you have the correct units, because the units are your friend. If you end up with the correct units, no matter how you got there, because there's more than one way, then you'll have the right answer. So we're going to start with a simple one here. Okay, 1.76 yards to centimeters. Now, if you look on your sheet, there's more than one way to do this, right? So if you look on your sheet, you may find that you like or you prefer another way. So you are given only one number, 1.76 yards. So obviously that's what we're going to start with. So we have 1.76 yards. And I want centimeters. So way over here, I'm going to say equals centimeters. And my job is to get closer to centimeters. So in America, where we use the English system, we have to convert to metric quite a bit. And so that's one of the main reasons why dimensional analysis is so important here. Yeah, I know in nursing, we use pounds, but they use kilograms in nursing. So you got to be able to convert those numbers. And so a simple one from yards to centimeters. The first thing I'm going to do is I'm going to say, okay, yards. I don't know what the direct conversion is from yards to centimeters. But one of those numbers that they give us on our conversion chart is that there's 1 meter in 1.094 yards. So they're almost the same. Okay, now what I have to remember is if I have yards here, I need to write yards here. Okay, because what I want is if I have a yard on the top and a yard on the bottom, I want to be able to cancel those out. That tells me which way I write this conversion chart, this conversion factor. So the conversion factor is going to have to be 1.094 yards, and the 1 meter is on top. Once I've done that, if I have yards on top and yards on bottom, yards goes away, because yards divided by yards, as we saw in the earlier slide, is 1. Okay, so now I have meters. So I'm going to write meters. Okay, if you'll do this each time, it will guide you to the answer. So I've got meters here. I look back at my destination. I'm trying to get to centimeters. So I know if I look back on my conversion that there are, in 1 meter, there are 100 centimeters. Now you could write 1 centimeter is 10 to the minus 2 meters. That's quite all right. If I can avoid exponents when I'm doing calculations, I do. All right. So once I've done this, meters goes away, and I'm left with centimeters. And centimeters is really what I want. So I'm done. So now all I'm going to do is I'm going to say 1.76 times 100, which is 176. And then that's divided by 1.094 times 1. And so when I do that math, I'm going to get 160.8775. So how do I know how many significant figures to use? All I worry about is my measurement, because that's the only one with the uncertainty. And since I had 3 significant figures in my measurement, then I have 3 significant figures in my answer. So we took yards and got rid of yards by finding a conversion factor with yards in it. And you could have done this with feet, you could have done it to inches, you could have done it several different ways and still gotten centimeters. It doesn't matter how you get there, as long as you get close. And that's one reason why I don't get real caught up in you're off by a decimal place, because if you use another conversion factor than I do, you may be off from my answer just a little bit. Okay, if I didn't give you some leniency on that, I would have to require that you use the same exact conversion factors that I do, and you do everything exactly how I do, and I'd really rather you use your brain. Okay, so then you have 1.8 quarts to cubic centimeters. Remember what cubic centimeters are the same as, and so you're going to work that one. And then I have another where you're going to convert cubic centimeters to gallons. And this, I'm gonna show you how to do this one, just because this is where you're going to have to use cubes or squares or whatever when you're doing this, and it works pretty close the same way, but just a little bit different. Something you have to watch out for. Okay, so oh wait, no, you don't have to do it on this one. I'll do it in a minute. So this one you can do because 9255 cubic centimeters is the same as 9255 milliliters. So just remember that, and you'll be able to work that one. Okay, now this is the one I wanted to show you. This is the one where you've got cubes, okay? And so calculate the displacement, that's how much the water or the piston moves, of a 5.7 liter engine, and you want to convert that to cubic inches. Okay, so I've got 5.70 liters. And over here, and I give myself plenty of room just in case I get carried away, and I want that in inches cubed. All right, so I've got to get rid of liters, I know that. And sometimes you can just wander. So I've got 5.70 liters, so I know I'm going to write liters on the bottom. And so let's see. Well, I know the quarts and stuff like that won't get me anywhere, right? So I'm just gonna go ahead and change it to milliliters. I just want to get rid of the L for now, okay? Now, I do know, and I know that I use this one quite a bit, that there's 1 cubic centimeter in 1 milliliter, and this thing over here is in cubes. So I'm thinking that I may need something with cubes in it. So if I know that there's 1 milliliter in 1 cubic centimeter, and that will get rid of my milliliters. So next I'm going to get rid of my cubic centimeters. Well, I don't know about this whole cube thing. What I do see though on my sheet there is that 1 inch is the same as 2.54 centimeters. Everybody see that? If you look on your conversion chart. Okay. So I could say 1 inch, because that's where I'm trying to get to, is inches, is the same as 1 cubic centimeter. Then 1 cubic inch would be how many cubic centimeters? 2.54. 2.54 centimeters. Because 1 inch is 2.54 centimeters. So 1 cubic inch is 2.54 cubic centimeters. Now, where you got to watch out is if I cube this, I got to cube that number. All right, so I'm cubing 1 and inches on the top, and I'm cubing 2.54 centimeters in the bottom. And when I do that, I'm going to get rid of cubic centimeters and be left with cubic inches. And that's what I'm looking for. Okay, and so I'm there. All I got to do now is the math. Now, I'll tell you right now the answer is 348 cubic inches. How do I get there, though? How do I get there, though? Well, I'm going to say 5.7 times 1,000 times 1 times 1 and that's going to be 5,700, I believe. And then 1 times 1 times 2.54 cubed. Okay, this is one of those times where it's super important that you're doing this with your calculator, because you need to see how do you do cubed. Well, there is a little button on most people's calculators that looks like that. It's called a capsula. So you enter 2.54 capsula 3. So I'm doing that right now. And that's going to equal 16.387. Okay? So you're going to end up over here with 5,700 divided by 16.387. And don't round until the end. Okay? Don't round until the end to get your significant figures. You can leave all of those decimals in there. And so when you get done, you end up with 347 approximately 0.835. Now, I get all kinds of questions. Oh, I got 347.823. Okay, I don't care. All right? Because it's 3 significant figures. It's still going to be 348. If you have one that makes it change from 348 to 347, you might want to look back, make sure you're right. But the thing about chemistry is if you show me you worked it correctly, which you will on your exams, then you're okay. All right, so don't get all caught up if your decimal's off of something or something like that. It's fine. And so I gave you a couple of things to practice with on this as well. Okay? Now, one thing we can use as a conversion factor that I haven't talked about yet is density. We looked at rearranging the formula to work the density, but you can also use the density of something as a conversion factor. So if it gives you the density, you're probably going to use it for something. Okay, so in this particular one, you have a mass of fuel needs to be calculated before each flight, because if your jet is too heavy, you won't make it. Sounds pretty important. So 747 is fueled with 173,231 liters. Okay, that's a volume. The density of the fuel is 0.768 grams per cubic centimeter. That's the density. What is the mass? So the mass is what I'm looking for. Now remember I told you density is the bridge between volume and mass. So you can start out with a volume and you can end up with a mass. So how we set this up? Well, what do I use first, you ask? Well, what can I hold in my hand? I don't want to, but I can't hold density in my hand because that's a calculation. But I can hold some liters of fuel in my hand or in a beaker or something like that. That's the measured quantity, so that tells me that's what I'm starting with. So 173,231 liters. And I know that the units of my density are in cubic centimeters. So I know that I need to get liters to cubic centimeters. Okay, because getting all of these things the same is important. And so I can do it this way, or I could have tried to do it at the beginning. Either way you want to try. All right, so first I'm going to have to get this to milliliters and then to cubic centimeters, or you could, since you know it's the same, just do it in one step. I'm going to do it in two just so I don't lose anybody. Okay, so 1 liter is 1,000 milliliters. I got rid of liters. I need to get rid of milliliters. So 1 cubic centimeter is the same as 1 milliliter. I get rid of milliliters. Next thing I got to get rid of is cubic centimeters. Now, I have something over here that's got cubic centimeters in it, so I'm going to use that. I have 0.768 grams over 1 cubic centimeter because that is the density of the jet fuel. I got rid of cubic centimeters. Now it wanted the answer in kilograms. So the final thing I have to do is I have to say I've got to get rid of grams. So there's 1,000 grams in 1 kilogram. And some of these you'll get to where you know what they are. Okay. So then to solve it, I'm going to say 173,231 times 1,000 times 0.768 times 1. And I do all of that. And if you're not a super guru on your calculator, please do it this way, especially on a test, so that you won't mess up. If you do your parentheses correctly and you're a math genius and you've taken calculus and all that stuff and you know your calculator inside and out, it's fine. But if not, I really strongly suggest that you do it this way, at least at the beginning. Okay, so you're going to multiply all of those things on the top, and then you're going to divide them by all the things that you multiplied on the bottom. In this case, it's pretty easy because it's just 1,000. And so you're going to end up with 133,041 kilograms. Okay, now I'll tell you a little rule of thumb on scientific notation now. If you're going to have a number that's bigger than 1,000, typically I like for it to be in scientific notation, unless I ask you to do it a certain way. So if you gave me that, I wouldn't count it off, but by convention, most people do this, so it's good to get in the habit. So I'm going to have to go over 1, 2, 3, 4, 5. So my answer is going to be 1.33041 times 10 to the 5th. But now I've got to think about significant figures. So I'm going to go back to my original number, and it had 1, 2, 3, 4, 5, 6 significant figures. So 1, 2, 3, 4, 5, 6. That's my answer. Not shabby, is it? And that's in kilograms. We got to remember to put our units, because if somebody put that many grams in the airplane, it would take a ditch into the ocean probably on its way somewhere. All right, so these are important. Your units are important. These calculations are important. It's important that you learn how to figure this out. And I give you plenty of practice on these, okay, so that you can go back and you can get some practice with your milliliter cubic centimeter conversions, and then also using your density. And that's it for dimensional analysis.